Welcome back to AI Unraveled, your essential daily briefing on the real-world business impact of AI. Today, we interrupt the daily rundown for a critical special episode, a deep dive into the Generative AI Revolution, 2025 and beyond. We're talking about the fundamental re-architecture of the enterprise. We have broken down a comprehensive new report that charts the strategic battles between closed-source titans like OpenAI and Google, and the fiercely competitive open-source challengers. This isn't just theory. We reveal how GenAI is forcing a re-architecture of workflows across finance, healthcare, and software development, creating entirely new value streams. But first, a word on why most enterprise AI initiatives fail. There's a reason they never make it to production. You can't find a platform that's both powerful and secure enough. The result? AI budgets burned with zero business impact. But not anymore. AIRIA is the enterprise AI platform that delivers speed without compromise. Unlike platforms that force you to choose between fast deployment or secure operations, AIRIA brings speed and security together. Launch quickly without cutting corners on compliance. Scale rapidly without sacrificing governance. Ready for AI at full speed with zero compromise? Visit AIRIA.com to see the platform in action. That's AIRIA.com. Simplify Enterprise AI. When we return, we analyze the 3 key trends that will define the future, from multimodal systems to the escalating need for better governance frameworks. This is your competitive blueprint for moving beyond pilots and achieving real, scalable enterprise adoption. If you rely on this show for your strategic insights, please take a moment right now to like and subscribe to the podcast. Now, let's unravel the future of generative AI. Stick with us.
Okay, let's unpack this. Generative AI, it's really rocketed past being just, experimental. It feels like it's now a core force reshaping entire industries. We're not just talking about writing a blog post anymore or making a neat picture. It feels much bigger now, like it's about architecting fundamental workflows and, frankly, deciding where billions in enterprise value are going to land. So your mission today, if you choose to accept it, is to get a quick but really comprehensive handle on this accelerated 2025 landscape. Our source material digs into the core tech engines, the really fierce multi-lane competitive battles happening right now, the profound industry transformations already underway, and importantly, those significant non-computational costs that seem to determine success, this whole idea of the trust tax. So we're going to distill those core architectural pillars, transformer and diffusion models. We'll chart out the 3 strategic lanes we see emerging in the competition. We'll examine GenAI's explosive impact across key sectors like software, healthcare, finance, and then confront those future risks, really zeroing in on that trust tax.
Right. And I think it's crucial we kick things off with that foundational distinction, because this is where generative AI it really earns its revolutionary status. It's not like traditional AI, the discriminative kind, which just classifies or predicts based on existing data, telling you if there's a cat in the photo or forecasting a stock price. Generative AI creates new, original content. It learns the deep patterns, the structure within massive data sets, and then produces genuinely novel stuff. Coherent text, photorealistic images, even functional code. And the breakthrough, the moment that really unlocked large-scale generation that came in 2017, there was this paper, Attention is All You Need. I think everyone in the field knows it. It introduced the transformer architecture. And that is basically the bedrock of every major large language model, or LLM, today.
Okay, so what was the specific change with the transformer? Because I remember before that, attempts at long text, well, my models would just forget what they were talking about halfway through.
Exactly. It solved that problem of context, specifically global context, almost instantly. The core innovation is the self-attention mechanism. See, instead of reading word by word, sequentially, the transformer looks at all the data points, all the words, simultaneously. It uses these things called query, key, and value vectors to weigh the importance of every word relative to every other word.
Yeah.
That's how it gets that global context.
So it can understand that the word lies means something totally different in, say, speak no lies compared to he lies down to rest, even if those phrases are far apart.
Precisely that. And crucially, this ability to process everything at once, this parallelization, that's what made training these massive LLMs feasible on modern hardware, on GPU clusters. The scale and speed just exploded. So that covers language, code. But for images, we look at a different beast. The diffusion process.
Right, diffusion models. These power tools like DALL-E 2, Stable Diffusion. It sounds almost counterintuitive, though. How do you create sharp images by starting with, well, noise?
Yeah, it does sound a bit strange. Think of it like reversing entropy. but maybe simpler. Imagine you have a perfect photo. You first teach a network how to gradually turn that photo into pure static, pure Gaussian noise, step by step. Lots of steps. Then, for the reverse process, you teach it how to perfectly undo that statification, starting from pure random noise, but guided by the text prompt you give it. It just iteratively cleans up that noise layer by layer until, bam, you get a completely new high-quality image matching the prompt.
Okay, that makes more sense. Iterative refinement. And what's fascinating looking at the sources is that the most powerful creative tools now are actually hybrids. They use both architectures.
They absolutely are. It's a smart combination. The transformer part handles the brains, the semantic understanding of your prompt, the what you want. It translates that complex human language into a precise numerical sort of instruction set. Then the diffusion model takes that instruction, that intent, and handles the actual pixel generation, the artistry, the how it looks, this fusion, this symbiosis. That's really the engine driving the crazy progress we're seeing in creative software right now.
The architecture is definitely impressive. But shifting gears to the market, the competitive landscape seems way more complex than just, open versus closed source. Our sources suggest it's fragmenting into 3 really distinct strategic lanes. Okay, so lane 1, the platform play. This looks like the domain of the giants OpenAI and Google. Their goal isn't just having the best model, right? It's about becoming the central OS, the intelligence layer everyone else plugs into. OpenAI with GPT-5, their agent kit, they seem to be pushing ChatGPT towards being the platform for business intelligence.
And Google's playing the scale game hard. Gemini 2.5 Pro, for instance, boasts this enormous context window up to 1 million tokens. That's huge. And their strategy is deep integration across their whole ecosystem, workspace, search, everything. It's aiming for that powerful lock-in, making Gemini the default brain for any enterprise already using Google Cloud or Workspace.
Okay, then you got lane 2, the infrastructure play. This is where companies like Meta and Mistral come in. Meta's Llama series with those permissive licenses. It feels like they want Llama to be the Linux or maybe the Android of AI. But isn't that strategy a bit risky? If you essentially give the core tech away, how does Meta capture value compared to Google's lock-in?
Well, the sources suggest the value capture shifts. It's about setting the standard. By commoditizing that foundational model, they push the huge compute costs of running and tweaking these models onto the community, onto other businesses. And when everyone starts building on top of Llama, Meta influences the direction, the tools, and they can eventually monetize the layers above that free base model. It's a long game. And Mistral is really important here too. They're focused on capital efficiency, how to get top performance without bankrupting yourself on compute. They use clever architectures like Mixture of Experts or MOE. You see that in their Mixtral models. Think of MOE like having several specialized AI teams within one model. For any given question, it only activates the right expert team. So you get really high performance, but it costs way less to run than a single giant monolithic model that tries to do everything at once.
Efficiency matters.
We'll get right back to the episode in a moment, but if you're listening, you already know the caliber of our audience. There's a reason most enterprise AI initiatives never make it to production. You can't find a platform that's both powerful and secure enough. The result? AI budgets burned with zero business impact. But not anymore. AIRIA is the enterprise AI platform that delivers speed without compromise. Unlike other platforms that force you to choose between fast deployment or secure operations, AIRIA brings speed and security together. Launch AI quickly without cutting corners on compliance. Scale rapidly without sacrificing governance. Move at the speed of business without moving past your security requirements. Fortune 500 companies across finance, healthcare, retail, legal, and more choose AIRIA because we deliver what seemed impossible. Enterprise AI that's fast enough to beat the competition. Ready for AI at full speed with zero compromise? Visit AIRIA.com to see the platform in action. That's AIRIA.com. Simplify enterprise AI. Back to the show.
Okay, finally, lane 3, the niche dominator play. So these companies aren't trying to boil the ocean. They're focusing.
Exactly. They target specific, high-value problems in defined markets where generic models might fall short or carry too much risk. 2 really clear examples jump out. Anthropic, with Claude 4.1. They heavily promote constitutional AI. Now, this isn't just marketing fluff. For industries like finance or healthcare that are super risk-averse, it's a vital safety feature. The model is designed from the ground up to refuse prompts that violate certain ethical rules or legal constraints. So they offer a kind of pre-vetted, safer system which helps solve compliance headaches.
And Adobe Firefly in the creative space seems like another perfect example. Why are they dominating with creative pros?
Because of the data. They train Firefly exclusively on commercially safe content, mainly Adobe stock images and openly licensed stuff. This tackles the massive intellectual property risk. Companies using Firefly don't have to worry nearly as much about accidentally infringing copyright, which is a huge fear with other image generators trained on, well, the entire internet.
Okay, we've mapped the tech and the players, but where is all this power actually hitting the ground? The sources seem to emphasize that the real shift isn't just task automation, it's more fundamental.
That's the core insight, really. The biggest value isn't just making one task faster. It's about fundamentally re-architecting entire workflows around what AI can now do.
Let's take software development. It's gone way beyond just suggesting the next line of code, hasn't it?
Oh, absolutely. The whole software development lifecycle, the SDLC, is being reshaped. AI is now doing things like automated testing, generating complex unit tests, UI test cases directly from the user stories, finding bugs earlier, and maybe even more importantly, it tackles a chronic pain point in almost every large tech company, understanding legacy code bases. AI can automatically generate documentation and explain complex, often ancient code in plain English. This dramatically speeds up onboarding for new developers, which used to take months.
And in healthcare and life sciences, the sources talk about incredible speed-ups in discovery.
Yeah, the pace is changing dramatically. In drug discovery, for example, models are designing and validating completely new molecular structures in silico. It's all virtual. We're seeing examples like in silico medicine mentioned in the sources, taking a drug candidate from initial discovery to phase 1 clinical trials in under 18 months. That's a tiny fraction of the traditional timeline and cost. It fundamentally changes the economics and risk profile of pharma R&D.
And for doctors on the front lines dealing with burnout, which is a huge crisis, what are the practical applications there?
Yeah, AI is directly tackling that administrative burden. On one hand, you have personalized medicine advancing with patient digital twins. These are virtual models used to simulate how different therapies might work for a specific person. But maybe more immediately impactful are the ambient listening tools, like Nuance DAX Copilot. These tools basically listen in on the doctor-patient conversation securely, of course, and automatically generate the structured clinical notes needed for the electronic health record, the EHR. That frees up doctors from hours of typing notes after hours. Honestly, if my own doctor wasn't glued to a screen half the time, maybe I'd feel a bit more listened to.
That's a huge potential benefit. Okay, and quickly, what about finance? Highly regulated, data heavy. How's GenAI fitting in there?
Finance is prime territory, despite the risks. GenAI is boosting fraud detection significantly. One way is by generating realistic synthetic data representing new, clever fraud attempts. You use that synthetic data to train and stress test your existing fraud detection systems, making them stronger. And for risk management, think about compliance. Models can rapidly scan thousands of complex legal docs, contracts, regulations, identify risks, ensure compliance, even help automate drafting regulatory filings. MasterCard, for instance, reported their GenAI tech doubled the detection rate for compromised cards while slashing false positives. That's real bottom-line impact.
So we've seen the engines, the players, the initial shockwaves in industry. Now looking ahead, maybe the next year or two, the landscape seems defined by this leap towards autonomy.
That seems right. And it looks like it's driven by two converging trends. First, moving beyond just processing one type of data well. We're shifting to large multimodal reasoning models, or LMRMs. These use something called multimodal chain of thought, MCOT. What that means is the AI can actually reason coherently across text, images, audio, video, all at the same time, not just process them separately. Gartner actually predicts 40% of GenAI models will be multimodal by 2027.
And this true multimodality, this reasoning ability that enables the second big shift, autonomous agents. So we're moving away from AI as just a co-pilot helping with one specific task, like write this email draft for me, to an agent that can perceive a goal, break it down into steps, plan, and then execute those steps using different tools, maybe across different applications.
Exactly, and this has huge implications for human roles. Instead of doing the task directly, your job becomes more like an AI orchestrator or maybe an intent engineer. You're the one setting the high-level goal, defining the intent, and then managing or overseeing a team of AI agents that actually perform the work. Your role shifts upwards strategically.
That brings us to the really big, maybe slightly unnerving question. The quest for AGI, artificial general intelligence. The timelines here seem all over the place. Academics tend to be more cautious, maybe a median around 2040 to 2060. But then you hear AI leaders, people actually building these systems, talking much sooner, 2026 to 2030 sometimes. Community prediction markets seem to reflect that acceleration, often landing around 2031.
It's a huge spread, reflecting deep uncertainty. But this acceleration, this optimism from the builders, it's also rightly tempered by serious caution. We absolutely have to acknowledge voices like Geoffrey Hinton, one of the godfathers of deep learning, who's been publicly warning about the potential existential risks. His point, and others, is that safety research must keep pace with capability research. It can't be an afterthought.
Absolutely. And speaking of caution and potential downsides, that brings us back to the trust tax, because the economic promise is massive, right? Goldman Sachs projected something like a 7% global GDP boost eventually. But the sources highlight these very real practical and ethical hurdles complicating that picture.
Yeah, the potential is huge, but actually deploying this stuff reliably and safely at scale runs into problems. Organizations are already wrestling with what some call work slop, statistically low quality, often subtly wrong, AI-generated content. The irony is, it can actually decrease productivity if you spend more time finding and fixing the AI's mistakes than you would have spent doing it manually in the first place.
And we can't just ignore the environmental footprint either. Training these monster models takes incredible resources. Data centers need staggering amounts of electricity and water. The projections are pretty sobering. Global data center electricity use, largely driven by AI now, could hit 1,050 terawatt hours by 2026. That would rank data centers collectively as the world's fifth largest electricity consumer, like a major country.
And all these issues, the potential for bias, generating misinformation, the copyright battles we mentioned, the environmental costs, the work slop, they all feed directly into this concept of the trust tax. It's not just an abstract ethical concern, it's becoming a core business issue. It represents the cumulative non-computational cost, the investments in time, money, governance, security, legal checks needed to address these risks. If a system can't demonstrate it's safe, or that its output has clear IP provenance, or that it's reliable, its value in a serious corporate setting plummets. Paying the tax becomes the price of admission.
You can see this tax being levied right now in the legal domain. You mentioned the U.S. Copyright Office. They've basically ruled that only works with sufficient human authorship get copyright. Just giving a prompt to an AI, probably not enough. So, demonstrating that human involvement, ensuring the system is transparent, legal, safe, that is paying the trust tax, it's becoming table stakes for commercial use.
Absolutely. Navigating this generative age successfully seems to demand a really human-centric approach now. Just having the most powerful tech isn't enough anymore. Success increasingly depends on proactively integrating safety, transparency, ethics, basically, paying that trust tax from day one.
Okay, so we've talked about the trust tax and the immediate regulatory challenges. Looking further out, maybe towards embodied AI, autonomous agents acting in the real world, what's the single biggest policy question the sources leave us wrestling with for, say, the next 5 years?
Well, the trajectory described seems clear. From LLMs to these multimodal reasoning models, LMRMs, then to autonomous agents, and the final step seems to be embodied AI. Systems that don't just process information, but can actually act in the physical world, robots, drones, etc., powered by this intelligence. So if that future of work involves many humans shifting from doing tasks to becoming these AI orchestrators, managing teams of digital and physical agents, the biggest question then becomes, what new kinds of inequality arise? What new regulatory challenges emerge from the gap between the orchestrators, who retain high-level strategic control and value, and those whose more routine cognitive or physical tasks get fully automated and are essentially managed by the machines under the orchestrator's direction? That potential gap, the wealth and power disparity between those commanding the agents and those competing with them or replaced by them, that feels like maybe the deepest societal challenge this next wave of AI presents.
That's it for today's deep dive. We hope you walked away with actionable insights for your enterprise strategy. Before you go, let me remind you of the unparalleled value of this platform. AI Unraveled delivers deep, uncompromised technical insight that keeps our audience, senior enterprise leaders, tuned in to the very last minute. That sustained attention is the best place for your ad. This is your opportunity for a direct line to your most valuable buyers, the CTOs, VPs of engineering, and MLOps heads who sign off on high-stakes infrastructure. Stop wasting budget on general marketing noise. Secure your high-impact premium ad campaign right here. Email us today to reserve your mid-roll package, info@djamgatech.com. Thank you for listening to AI Unraveled. We'll be back tomorrow with more.